Stop making lazy gifts. If you want someone to really appreciate your gift, you have to put in some real thought into it.
Handmade gifts will always be superior than ones that are store-bought, and one of the best outlets to create gifts is the Raspberry Pi, a mini computer that allows anyone to create anything they want to, as long as it's in their budget. Okay, so in 2 weeks it's my dad's birthday, and I just came up with the perfect gift for his birthday. For context, my dad loves plants. He's been collecting them for over 15 years, but there is a problem. He needs to water his plants almost every week, but he's not getting any younger. So I decided to make an automatic plant water that waters a plant when the soil is dry. Before I begin, these are all the components I need. And for the water pump, make sure you have a DC pump and not an AC pump. It will not work if you have an AC pump. Okay, and so once I had all the parts, I began, but then I had no idea where to start. After consulting a professional, I found out I needed to download the Raspberry Pi software as well as insert code into one of my micro SD cards. But in order to code on the Pi, I needed the IP address of the Pi. So after hours of troubleshooting and watching random YouTube videos, I found out that the network my Pi was connecting to was a guest network, which hides its IP address. And after spending so much time on this, it was just as simple as switching networks from a guest to a regular network. Anyway, after inputting code that would allow me to access the Pi from my computer, I decided to move on to the hardware. I started with a breadboard, which allows me to connect electrical currents if they're in the same row, and I inserted my MCP3008, which translate analog signals to digital signals. A good comparison for this would be if you asked your friend how much water is in a glass, and if they had the MCP, they would say it's 67% full, but without it, they could only say if it's full or empty. And while wiring the MCP from the breadboard to the Pi, I had to look up what each pin of both machines did. And here are the images of the pins if you want to follow along. Now at this point, it was my dad's birthday tomorrow, so I really have to hurry up and get everything done as soon as possible, and I still have a decent amount of stuff to do. The next thing I did was connect the moisture sensor to the Pi as well as the MCP. Keeping this momentum, I moved on to the water pump, and I mean, what could go wrong? Yeah, I bought the wrong kind of water pump. I bought an AC pump instead of a DC pump, and I needed to buy another, which means that I couldn't make the gift on time for his birthday. After a couple of days, the new pump arrived, and I was able to move along at a pace. Yeah, when I couldn't finish in time for his birthday, that really deterred me from even trying. But then I realized he'd still rather get a late gift than no gift. And so I continued, and the next thing I did was tape the wires from the new DC pump to the Pi and the MCP using tape, which I probably should have used electrical tape, but the risk of fire isn't too high, right? I plugged it in, and the pump was working fine, but it was kind of strange. It went into full power whenever I plugged it in, and even when I had the Pi plugged in as well as the pump, it still went full power. The two have different power sources, because if I had the pump get power from the Pi, it would fry the Pi from the pump, requiring more power than the Pi can provide. Continuing, I moved on to the software side of things, and the first step is to connect my Pi to my PC. Once I was in, I tried to connect and control the pump remotely from my PC, but it wasn't working at all. Whenever I plugged in the pump, it just went to full power no matter what, and even with the Pi plugged in correctly, it still went to full power, which was definitely not supposed to happen. For elaboration, the pump goes through the IRLZ44N, which is supposed to act as a middleman for the pump and the Pi. So the pump is not supposed to go off on its own without me giving the command it to. And after way too long of troubleshooting and asking said professional, I had a revelation. I am an idiot. the IRZ44N legs were all in the same row, which meant that any jumper wire in the same row as those legs couldn't decide which of those 3 legs to connect to. And after fixing that problem, I sailed ahead. Except I didn't go far. I ran into another wall, although this time it was not too thick of a wall. My moisture sensor would keep returning the same value of moistness, and it wasn't giving the correct values that it detected. Thankfully, a little later, I figured out that I had wired the MCP a little wrong. So I fixed that, and then boom, it worked like a charm. Then I double checked everything and tried to run it as a whole instead of individual components. The final test that would determine the fate of humanity. I ran the command on the computer and it worked, surprisingly, and I was shocked and happy at the same time. The orchestra of parts was singing beautifully for the first time, and I was here for it. Now, to explain everything in simple terms, if you don't want to hear about how the machine processes stuff, go to this time step. Okay, essentially there are 3 parts that the system goes through. First is sensing, second is processing, and the final is actuation. For the first part, the sensing, the analog moisture sensor gets information about how dry the soil is. Then the signal goes through the MCP 3008, where it translates the analog signals into digital signals, which is required by the Pi in order for the Pi to read the information. Once it reaches to the Pi, the second step is executed. The Pi runs the code and determines if the soil moistness meets the threshold that I set. If it isn't at the threshold, nothing happens. On the other hand, if it does meet the required amount of moistness, the third step is executed, and a signal is sent from the Pi to the water pump. But in between the two is the MOSFET, which acts as a switch for the pump and makes sure it doesn't power on when it isn't supposed to. The pump then spits out the water into the soil for a couple seconds from receiving the signal from the MOSFET. The code automatically repeats this process every 2 seconds, which can be changed in the code if desired. Speaking of which, the link to the code is provided down below in the description via GitHub. After all that hard work, I would say that's easily worth the struggle. When I presented the gift to my dad, his joy spread to me and replaced my feelings of anxiety. He really appreciates the fact that he has fewer plants to water, and every week he has less pain to go through. And the feeling of making something that is your own for somebody else is immeasurable, and I do it 100 times over. Even though I ran into a lot of obstacles, it was fun, and it just goes to show that you don't need 15 years of experience. All you need is to have fun and try to persevere through the tough times. Because if you're imprisoned by self-doubt, you'll never make a meaningful gift, let alone do anything heartfelt. Thank you so much for watching this far. It really means a lot to me, and if you want more content like this regarding tech, the best way to do that is to follow me. Anyway, I hope you go out and make something amazing.